to do. Okay, great. All right. So, how many people here? How many people here saw my video yesterday that I posted? Cool, cool. Yes, there was video posted yesterday. We're going to talk a little bit about that today. Well, I really wish there were more of you. Because today is one of the shorter labs I have to teach you, which is great because I am also going to have it where you can make up some labs today.
I think I see the video yesterday.
That's fine. Also,
Sorry.
you're good. All right. We are going to, let me actually share this on Canvas. All right. So today, my video, and I will go over what was in that. Hold on, let me post an announcement with this. There we go. Keep speaking. All right. The labs, I talked about late labs. That was the first thing that I talked about, and how we're going to be changing up a few things heading into the second half of the semester. So one of the things I would like to discuss is all right. So my policy is typically there are no late labs, but I understand the semester there are a lot of extenuating circumstances. We have some bad weather one day, and so on. So what I'm going to do is today you'll have a chance to make up a lab, which is also why I'm really sad there's not more of you here because I know more of you need it. But today was going to be a makeup day because we have so much extra time today. My lecture will be very short in comparison. All right. So additionally, hang on 1 second. on stream talking to. So, all right. Today we're going to talk about metamorphic rocks. This is the shortest lecture you'll have from me because we have talked about most of the things that go along with metamorphic rocks already. So this one, we're going to kind of take the knowledge that we have from igneous and sedimentary and filter it into metamorphic rocks. And you'll see how some of these concepts kind of come together in a very simple way, because metamorphic rocks are the simplest rocks to teach, are the absolute simplest rocks to teach. So we're going to start off with our listen. So we're going to do a little video, right? So we're going to have Bill Nye for a minute. Just give a 30-second introduction here because I love this guy.
Sort of a combination of the other two. Call it metamorphic. Metamorphic means it's changed. It's metamorphosized. So if you look at this, this is rock that was once sand, but it's been smushed together by huge pressures under very high heat, pressure and heat, smashing the rock till it's just crushed flat like this. See, heat and pressure formed another rock.
Okay, so short as that was, it covered most of what we're going to talk about today. And I love Bill Nye. I just absolutely we're gonna have more of him as the semester goes on because it just gets more relevant. But we're gonna start with a few. There are 3 terms you're gonna need to know with metamorphic rocks. Just 3 things. Also, the easiest lab that we'll do. So metamorphic. So just like igneous or sedimentary, we can break the word down. We can break the word down to see what exactly is going on here. So when you see the word meta, with any, when you play like online games in here or anything, Overwatch or anything like that? Yeah. Okay. Well, you have sometimes what is a norm, right? It's called the meta. It is the thing that you typically see, right? So this is talking about the community of rocks, if you will, right? So, but morphic is about change. When you see morph, right? You've all watched Power Rangers as kids or as adults. I mean, it's fun.
I was hard. Yeah,
I know the new seasons aren't great. Anyway, moving along, I'm not going to let that fly right now. So when you have rocks that change, so a group of rocks that change, metamorphic. Okay, so Mr. Nye, in his infinite wisdom, said the 2 most important words that you need for metamorphic rocks. You are going to get so tired of hearing me say these in the next week because you're going to hear it a lot. So I'm going to write them real big. Heat and pressure. Heat and pressure. Heat and pressure. Heat and pressure. Heat, pressure. Heat and pressure. You're going to hear this a lot. So in that very short clip, which in 30 seconds he managed to sum up my lecture, which I thought, hey, listen, the guy's a pro. But I'm going to try and like stretch this out a little bit here. Okay. So he talked about how pressure, how being able to have something pushed down upon something can change a rock, right? So of course, when we apply pressure, and here we're going to get to the only other term you need to know. We apply pressure, you get layers, but they are called foliations. Foliations. Let me actually turn this off. Foliations. Okay. So, what is a foliation? What's a layer? What is a layer? So, do you remember last week when we looked at coal, right? And I told you that the coal was formed because of things that were constantly pressing down one after the other on each other, right? To give you this foliated structure. So let's actually tie this back even further to lab 2 for us. We talked about properties of minerals, right? So remember we talked about cleavage and fracture? Cleavage and fracture. So what's the difference between something that cleaves and something that fractures? What do we got?
Something that cleaves as a plane.
Okay, something that fractures.
Jagged.
Yeah, very good. So let's look at. I'm not going to break any of these because I don't want safety glasses and you guys sit too close. So I don't want to hurt you. But all right, piece of slate. So slate is what happens when you apply ridiculous amounts of pressure to shale. And you push it, and you press it, and you keep compressing it until it becomes this very thick, hard to break, still a little bit brittle, depending on where you happen to break it. But you can see that it still has these foliations, right? It still has these layers when you look at it at a side profile. So when something cleaves, that means at least on one plane, it breaks evenly, right? Has to break evenly at least on one plane. But this is called gneiss. This is gneiss. And gneiss is G-N-E-I-S-S. Okay? This is what happens when you metamorphose granite. And here we find another unique property of metamorphic rocks, where sedimentary rocks are formed when you break down other rocks, right? So you will not have a sedimentary igneous rock. You will have a sedimentary rock that was born from igneous material, but it will always have something else involved. But metamorphic rocks can be igneous and sedimentary, can take both of those rocks and change them. So with the application of heat and pressure. So how can you tell the difference? Because that's going to be the lab. The lab is going to be me putting 5 samples in front of you and you telling me which ones are foliated, which ones, basically which ones were formed through heat, which ones were formed through pressure. The difference is pretty clear when you look at these 2 samples. And this comes down to, again, something we learned all the way back in lab 2, is that cleavage and fracture. And it comes right down to that. What I'm asking you to do today, yes, it's more complicated than this. There's a lot more. There are some rocks that will challenge the nomenclature that I have here on the board, but most of the time, you'll be able to identify those rocks just by looking at them. Now today, again, as usual, I'm not asking you to know the names of the rocks, because remember, in this class, I don't want you to know the names. I want you to understand the process. I want you to understand the process of how do we get here. Not a matter of, listen, if you find somebody that can like name off like 100 rocks, and I'm calling myself out here, but they probably focus a little bit too hard on that one thing. I teach you it's different. Repetition is the soul of perfection. But the rocks here that we have, I'm not going to say, hey, you tell me what this is on the test. I tried that. I did. It ain't great. Because I understand that I put 24 rocks in front of you guys throughout the course of this class. And they are all different and have different ways to form and have different crystal sizes and have different temperatures and different compositions. No, we're not doing that. You're going to tell me how each one of these rocks form. So you're going to look at the rock, and if you see foliations, that means that there was more pressure involved. Now, there are some rocks that both can happen. You can get heat and pressure. So let's go back to igneous rocks, and we know that a lot of, we talked about the plate boundaries, right? Yeah, so how I was taught was, convergent, right? Divergent, transform. Okay, but we talked about the convergent boundaries and how one plate slides beneath another, right? So when that one plate slides beneath another, it melts, and that's where the magma comes up, and you get volcanoes, and you get igneous material, right? Sometimes what happens is not all of that material makes it to the surface. and it turns into a rock, and you get an igneous rock, but then it will start applying more heat, more pressure, and it will take that igneous rock and form it into something else, a bit like what happened with this granite. Took this granite and turned it into something else, and gave us this really cool looking gneiss. So, do you have any other slate? It's red quartz. Red quartz. Do you remember when I put when I showed you guys the sandstone, the red sandstone? Do you guys remember me showing you guys that in the last class? Okay. This is what happens when you apply intense amounts of heat to the red sandstone. The crystals, the sand, fuse together and turn into this very, very dense, very hard rock. This particular red quartz. All right. Most quartz that you see is metamorphic. So we'll have undergone usually either heat or pressure or both. Here's one from the kit, very shiny looking. But yes, this is one that has been under intense amounts of heat. So when you have to take marble and be like, yeah, let's see how hot we can get this thing. Okay, so heat, pressure, foliations. Heat, pressure, foliations. This is what you need to know for metamorphic rocks. Not only is this the shortest, it's easy. This will be very easy. And all I'm going to do is I'm going to take that's the lab. I mean, that's it right now. No, it's not. No, it's not. These are the same thing. And all you'll have to do is tell me whether it is foliated or whether it is formed through heat, because if it's foliated, it's mostly formed through pressure. So just remember, we understand the process here. You don't have to know the names. So on the midterm, when I ask you about this, I can guarantee you there will be a question asking about how metamorphic rocks form. It'll basically be what two processes are involved in the formation of metamorphic rocks. I might even phrase it just like that. And you will see heat and pressure. Also my multiple choice, if I haven't told you guys before. I have two questions. I have two answers that are very close to right. You might sit there and think about it. So I might say like heat and pressure and heat and not gravity, because you could apply gravity to pressure. Might do like heat and something else. I don't know. And then I'll put something like, I don't know, deposition and transportation, and I'll put something really dumb. I'll just put a really dumb answer that is like the meme answer, if you guys want to entertain me. So, okay. That's metamorphic rocks. But we're not done. We're going to talk about some of the stuff we've already learned. And you guys are going to talk to me. Yes?
So, did you say foliation can happen with heat too? It just means it's more foliation means pressure?
It is closer to pressure. There is always pressure involved when there are foliations.
Okay.
Yep, when something is foliated, there's always pressure involved. Yep. Actually, let's expand upon that question. What natural force is involved when you talk about pressure? What's gravity? Yes. Yep. The natural force involved when you talk about pressure is gravity. So that generally means if you have a rock that is formed through intense amounts of pressure, that generally means that it is probably underneath an immense amount of material, and therefore an immense amount of weight and pressure. Yep. Okay. So let's talk about sedimentary rocks for a minute. We're working our way backwards. And you guys are going to talk to me here. I ain't telling you, you're telling me. I'll tell you if it's right though. Alright, so, sedimentary rocks. Close your lab manuals, please. Close your lab manuals, please. Yeah, we're going to do this one together. Alright. So, do you remember the process in which sedimentary rocks are formed? Or we talked about this. I listed them out. There were two columns here last week, and I listed out that process. So when you take a rock, So a rock, let's say you take a piece of igneous material, right? And you want to make it sedimentary. What has to happen first? Okay, what is that process called? Weathering, that's right. Okay, we'll come back to you. All right, so weathering happens in two ways. What you got? Chemical? Yep. So we have chemical. Sorry, that's really loud. It's like there's like an engine running in here. And somebody else give me the other one. Mechanical, that's right. So remember, chemical is what happens when you break it down to atomic bonds. And the mechanical weathering is what happens when you take a rock. That did not break. Very cool. Well, I weathered it a little bit. There you go. So, and you drop it and it breaks. Great physical process. So, while we're talking about this, we talked about particle sizes. Right? Talk about particle sizes. So, on the test, you will have to know these particle sizes. Who can tell me the four?
Gravel,
What's that?
gravel,
Yep. Keep going.
sand,
Yep.
Clay. Clay.
Almost. There's one more before that.
silt,
Silt. That's right. And then we'll come back to you. Yes. Silt. And clay. You will be given a matching question on the test. That is, which one of these corresponds to the matching particle size? So the particle sizes are, I wrote them down in the during the lab that we had there, and they're also in your lab manual. But a real easy way to do this, a real easy way to ace this question is just to remember the order. Gravel, sand, silts, and clays. It's gravel, sand, silts, and clays. Just try and remember this, and you will have the test easily taken care of. All right, so the second process after you've weathered a rock, so you've broken down the material, you've taken that igneous rock, broken it down, what happens next? Anybody?
Transportation.
Transportation is correct. All right. Transportation. So let me ask you something. Which something small. If thrown into a moving river, which one of these two will travel farther?
Small.
Okay, why?
Because it's lightweight.
That's right. So what this tells you about transportation, the reason why we talk about this is because transportation, you know that if you have a smaller particle or a smaller object, it travels farther than a larger object. So the energy of the stream can push it farther because it does not take as much energy. So if you find something that has very fine particles, right? A sedimentary rock that is very, here, let's talk about. You guys know this one? What's this? That's right, it's a megatron. So this is very, very, as you can see, very fine. Very, very fine. Right? So that means that the particles of chalk could probably travel an incredible distance because just how small those particles are. Whereas if you take the gravel that was in your kit, right? Probably not as far. All right. So the third process, so we've broken it down, we've moved it, and the rock now runs out of energy. So, and yes, deposition.
do you want us to know the different types of transportation? Or just know?
The chemical and the mechanical you'll have to know, for sure. And the gravel, sand, silt, and clays for sure. But the other stuff, okay. Okay. I'll be honest, if I write it on the board, it's probably gonna be on the test. Most of the time. I usually try not to write things on the board that don't matter. Just to keep it where if you're taking notes, you're only taking notes about the stuff that matters. So, all right. So deposition is what happens when the rock runs out of energy or the particle runs out of energy and gets deposited somewhere. Falls into maybe the side of a river, a delta, a river delta maybe. We talked about that, I think. I believe we talked about deltas a little bit. So after deposition, not this time, buddy. I know you got this. What happens next? What's that? That's perfect. That is one of the components. The process in which compaction is a part of, what is that called? I'll give you a hint. It's rock making.
Sedimentation.
Almost. We're almost there. Keep going.
Lithification.
That's the one. That's the one. Lithification. Very good. Yes. Okay. Lithification. All right. So you've already gotten us started. You said what? Cementation?
No,
Well, I gave you the other one. So, all right. So there are two parts to this, the cementation and the compaction. So very good. All right. So lithification, compaction, cementation. So when something is compacted, what happens? What natural force is at play here? Gravity, that's right. So pushing down on something. And here again, we tie into a little bit of the metamorphic processes, where if you put enough pressure on a rock after it is deposited, you will start to metamorphose that material. Okay, and cementation is what happens when, let's see, I'll have you guys describe it to me. What happens when you cement a rock? Let me find the sample. Remember this? Right? Okay, show the people at home. Yep, so this rock right here, what happened here? It is cemented. How did that happen?
The earth ground.
Okay, we're getting there. Keep going.
Are you asking like pressure?
Yeah, you guys have to. I'm asking you guys to answer this. Yes.
A volcano.
Conglomerate.
Not quite.
Something.
What's that?
Conglomerate something like all this come together.
Yes, perfect. So you take objects, particles of different sizes, right? And if you remember, clay is the ultimate glue. So you take particles of different sizes and you encase other things inside of it. So as you can see, this has been cemented. Now, that is not always the case that you will get such large dynamic pieces like this. Sometimes you will find rocks that are cemented through different means. But what I'm showing you here, that's exactly how that happens. Where it comes together and it is almost glued together, right?
So like all cobblestones are segmentation.
That might actually be the case. I think of cobblestones, they're manufactured, right?
Sometimes.
I'll say if they're manufactured, man, see, that's a good question, actually. So sedimentary. Sorry for my handwriting. Great. Okay.
So to answer that question you just asked, we're just saying, so it just comes to me. How is it formed? Like
Yeah. It's like if you were to take, trying to think of the example. Okay, because I always think in terms of food, because of course. So if you were to take like jello, right? And you were to toss fruit in that jello, right? So you'd basically be cementing that fruit inside the jello. So the jello would be the cementing material. So imagine, yeah, actually that's probably a very good analogy. Imagine cemented material with jello. Is you're putting something in there, and that object is now cemented inside there, held in. by the wonderful, delicious Joe. So. Also, I'm hungry, so might get some more food references here. All right, so that is sedimentary. That is our crash course sedimentary right here. I will go through this more in depth in the actual when we do the actual review. I'm basically doing this because this stuff right here, and we're going to do one more for Igneous before I turn you guys loose on the labs. Do I have anyone here that needs to do lab 4? Okay, then we're going to do Igneous. Okay, because the stuff I'm asking you for is coming right from here. So when I ask you to identify the sedimentary rocks up here, I'm going to ask you to identify things you can kind of what details can you suss out of looking at that rock? And say, oh, it's got really small particles. So it probably was transported a great distance from where it originally came from. Or if it's a piece of gravel, you'll be like, oh, well, that stuff's obviously cemented in there. I'll ask you for 2 traits. And whether it was chemically or mechanically weathered is a pretty easy one if you know what to look for. I also encourage you before you do that to maybe brush up on your notes or brush up on in your lab manual itself, just to get a little bit more of a deep dive. That's what I did here. But yes, this is Crash Course Sedimentary Rocks. So now let's do the Igneous Crash Course. All right. Okay. So Igneous. Okay, so again, you're going to talk to me. Give me the 3 compositions, 1 per person. 3 compositions. So somebody give me, remember, you have, so yes, so you give me 1, very good, so Mafic. And Mafic gets you in just a minute, you're next. Mafic tends to be, give me something about its,
Iron.
okay, which means?
It's darker color.
So, yep. Iron. Darker in color. And one more thing, because it's higher in iron, what happens? That's right. Okay, what you got?
Isn't it folate? Folate?
Felsic. Very good. Yep, you're right on target there. Okay. Felsic is?
Lower in iron, higher in silicate.
Yes, perfect. Perfect. Which means it is what in color?
Less dense
So,
and lighter in color.
Perfect. Okay. One more. What you got?
Intermediate.
Intermediate. Yep. Okay, and intermediate is?
Equal in composition.
Yep, a good mixture. Yep. And what does that mean about the color?
Between light and dark color.
Perfect. Yep, in balance. In color. Okay, and here we're going to talk about your bonus points. So, what rock is this? It's my favorite. Trilite, right? Did you see that? Trilite? It's a bonus point on the test. Yeah, Rhyolite. Yep, okay. So, which rock is this? It's my least favorite. Andesite, that's right. This rock is what happens when you take the most mediocre thing and say, what if we made it into a rock? So, it's like the potted plant of rocks. It's terrible. Also, a bonus point on the test, if you can name my favorite and my least favorite. So, for people at home that don't show up, they will know. It's
Wait a second. You said we got to name like your favorite rock.
as I've said it every single class period multiple times, yes.
It's gonna be on test.
It's going to be a bonus point.
On the test.
Yes.
But I was asking.
Yes. This is why I want to give you guys opportunities for bonus points, and I will always every single class period that comes up. So yes, because This sample in particular is the one I think I paraded in front of you guys the most because it is one of the most dynamic examples of an igneous rock. And this one's mediocre, and this should probably turn into a potted plant. So, all right. So now that we have, so these are, there are two things. We actually didn't even give this a name yet. What are these? It's very good. These are its composition. And the composition is what it's made of. What makes up that rock? So if you have a felsic rock, let's take, right, so we have, rhyolite, okay? So rhyolite is felsic, is light in color. It's not that heavy. It's a very easy to handle rock. You won't, even if you have a large piece of it, you'll be able to, like, I don't know, probably impress your friends if you have a giant piece of rhyolite. You could probably lug this thing around compared to a piece of, like, basalt, which is ridiculously dense and hard to carry. So felsic, light in color and less dense because it's higher in silicates, right? Okay, mafic, darker in color. Mafic rock right here, right? What is this? Basalt, very good. Yep, so this is basalt, mafic. Where did this come from? Anybody? You're real impressed. Hawaii, awesome, yes. So this piece of basalt is actually kind of hefty for a rock that is only the size of my fist. And it is mafic. As you can see, it's very dark. I actually think the white markings are the chalk that's been next to. But yep. And the intermediate is the stuff in the middle. And as you can see, let me actually show you the contrast. So, felsic, really light. Okay. Mafic, really dark. Intermediate, somewhere in the middle. Born in mediocrity. So, all right. So next we need, in our next category, texture. Very good. This is like the light version of what we're going to do on Friday and Saturday. We're going to deep dive into what you need to know, or Friday or Sunday. I'm not sure which one it is. Okay, so the first two we need to know. The first two that we need to know. So you have some rocks that have, I like this one. This one's growing on me a lot. So, sample right here, and you can see that it has large crystals, right? As opposed to basalt, which you can't see that kind of texture, right? You can't see that. You can't like find an individual grain of basalt. Whereas this one, you can be like, wow, there are some very large pieces of things in here. So there's a term when something, we're going to start with the smallest. The smallest, and what is that? These small particles, the small crystals. Aphanitic, that's right, aphanitic. When we talk about texture, before we get too far into this, what are we talking about? There's a word I asked you to associate. Texture is associated with where something happens. Yes, so good, you're getting there. So what happens on the surface? It cools, that's right. Yes, very good, thank you for leading us there. Yes, it cools. So, when we're talking about texture, we're talking about cooling. Okay? All right. So aphanitic is small crystals. Where did this rock cool? If it's aphanitic, small crystals, the crystals did not have time to cool. What was that? Almost. It is the surface, yes. Put a pin in that and come back to that. Yes, cooled on the surface. So the word for that is, if I'm not an introvert, I'm an
Extrusive.
extrusive. Yes. I'm sure you guys understand that the word introvert could never be applied to me. Okay, so aphonetic, small crystals, extrusive. So what's next? Let's get the opposite here. What's the word? Phanetic. Okay. Which means, obviously, big crystals. Which means it cooled
Slowly.
intrusively, right? Intrusively, okay. Okay, intrusively. That is the difference between these two intermediate rocks, right here. So these two intermediate rocks, as if this might be a hint for your lab. So you see that this one, right, has large crystals, okay? Which means that this cooled inside here, this is diorite. This is diorite. I think this came from a countertop. Kind of pretty. And this mediocrity right here. Naturally, small crystals, which means it cooled outside here. Okay. Okay. We're going to come back to you in a minute. You got one, and we're going to be right there. There's one more that we talked about before we got to the last more dynamic ones. Do you remember? It is a word that starts with a P.
Violet.
What was that?
Violet.
Almost.
Floor. I can't pronounce it. Floor.
I think the three of you together are starting to like form this word because I hear different parts of it. Anybody want to take one last stab at it before I put it up here? Anybody?
Polyphoric, something like that.
Give me. Okay, let's actually do this in reverse. How can you tell a rock is this word?
Is a crystal inside of a crystal.
Perfect. Yes, which means what happened with cooling?
It started and then was forced out.
Perfect. Perfect. So we're gonna come back to rhyolite again because I can use this so often. So this piece of rhyolite has what looks to be like salt and pepper textures here, right? So this is a mineral called Potassium Feldspar. So what happens is this feldspar started to solidify inside the earth, right? And then the volcano this came out of was like, no, we're evicting you, out you go. But those crystals were still formed. So what happened was the lava cooled around the crystals, and we got this very dynamic looking texture where you have the very light in color felsic material, but encased inside, and we come back to like cementation, right? You could even say these are cemented in there, are these larger crystals. So, yes, and the word for that, one last stab. One last stab. What do you guys got? What's it? You're so close. Yes, it is porphyritic. I also think I misspelled that. But so cooled inside, finished cooling outside. Okay. Okay. You said an important word earlier. What was that? Something about
Water.
yeah, something about water. So when you have lava that makes contact with water, what do you get? Do you remember what texture you get? Or if you name the rock, that's fine, because there's only one we talked about. What do you got? What do you got? Let me give you a chance. It's okay. For the save.
Quartz.
For the save.
Glass.
Almost.
Obsidian.
Glassy. What is it?
It's obsidian.
Yes.
What?
Glassy obsidian.
Obsidian.
Yes. Yep. So it is glassy. That's obsidian. One more. So, yep, that's the same. What do we call fiery chunks, right? Pyroclastic, that's right. Pyroclastic, fiery chunks. Yep. So, pyro for fire, clast for grouping or chunk. All right. So, Pyroclastic. Oh, obsidian cooled with water instantly. Okay, pyroclastic. So pyroclastic, these can cool in a variety of ways, but let's associate a word with this.
Air.
And how does a rock tell you that it has air in it?
The holes in the middle of it.
And what is that called? It's a V word that we're going to associate with force. You are right. You're very right.
And then,
Vesicles. Yeah, that's right. So the pyroclastic will have vesicles. Man, I'm so impressed. My class is getting real sleepy. I had to do half this on my own. It was so sad. It hurt me inside. Okay. So this is yes.
So, I know when you did it the first time, you actually did it as a chart. Did you want us to know the chart?
No. The chart I was going to have the extra credit for this week, but we have enough going on. So I think what I might do is, because we're still going to talk about volcanoes and stuff and plate tectonics afterwards, I'm probably going to have you guys do that for extra credit immediately following the midterm. I'm also going to try to provide more extra credit after the midterm. I had intended on giving more, but man, this semester is going fast. We're like, what, 6 weeks in? Slab 6? Kind of crazy. Okay, so here's what's going to happen. This is, right here, the station for Lab 1, or Lab 6, not Lab 1. The lab we did today. Lab 6, okay? 1 second. Okay. All right. Lab, Sedimentary Lab will be right here. And this is Lab 5. The Sedimentary Lab is right here. And then the Igneous Lab is right there. So, Lab 6, right here. And all I want you to do is tell me whether it has cooled through heating or pressure, or whether it has been formed through heating or pressure, and give me a reason why. So basically, like, formed through pressure, you're going to say it has foliations. So, all right, this lab is, this one in particular is much easier. Hang on 1 second, actually. I'm going to end the stream.